Well, hello, good morning. Thanks so much for joining me in my shop here on August 31st. Oh my gosh, last day of August. And what I've got here is the receiver I've been working on the left. That's been out of my shop for a couple of weeks while I sorted things out with the instrument on the right, the TV alignment generator, which I'm pretty sure is going to be very useful in aligning FM radios like this one too. So my goal today, since I'm unsure of the receiver and unsure of the signal generator, my goal today is to simply get all this working in a test condition, and the very first sort of initial test condition that needs to be set up to do alignment work on the FM radio. So that involves my oscilloscope, the signal generator, sweep, marker, all this stuff. Trying to work together to get me to a place where I can then carry on with the FM alignment instructions, all this kind of stuff down here. Now, I've done a few videos on this, and then I set it aside and did a couple of weeks on this thing. I'm thinking it would only be a day or so. Now I'm back here again, and the way I remember it, I'm right at the start of the FM alignment. And one of the bugaboos about it was the pointer does not appear to be set in the right position right off the bat. That seems to be the case with the AM pointer too. So I'm in a little bit of a quandary as to whether I should move the pointer or if I should assume that whoever did the original alignment, probably a factory alignment, did something and I should leave it the way it is because they knew better. I'm going to make a decision around that. I have a circuit here that I've built, which is soldered onto the back of the receiver, and this is a special output to feed sweep signals or signals to the oscilloscope over yonder. That is also something that's a little bit questionable about how it operates. So I think my coffee is ready, so I'm going to stop, drink some coffee, and with a good charge of caffeine, go at it here. So just before I get this going, I wanted to check the schematic and look at the power supply here and see on the primary side that gets plugged into the wall, how have they handled that in terms of the chassis. And right here you can see a connection from literally right from the plug here, right to the chassis through a, look at that, huge 1,000,000 ohm resistor and a 10,000 pico, 10, so 0.01 capacitor, microfarad, 0.01 here on one leg. Now they don't show this to be polarized. The original plug, I don't think I have it. And what I am using, I've soldered in my own wire. Randomly, it's a polarized plug that I've soldered in temporarily. And it could be polarized the wrong way. I'm not sure about this at all. This should be the polarized, the big spade should be here, so it makes this connection. You reverse this, but you can't with the wide, spade here. If it doesn't have a wide spade on the original plug, you can plug it in this way or that way. Maybe it makes no difference with this great big resistor here. In my case, here in my shop, the receiver is being plugged into an isolation transformer. So there is no tie to hydro ground no matter what. Until I connect some equipment, which becomes the issue then. Well, that's why I'm looking at this. I'm just taking a look at it. I have had stuff hooked up to this and didn't have any trouble. I don't remember really looking at this before. So again, very large resistor here, probably no problem at all. Okay, so this, where I plug my projects in, this goes back to an isolation transformer under my bench. So there's no power system ground brought up here. In fact, this monitoring device that I just use here, you can see the ground plug of it is just sticking out in space. This is a two-prong extension cord. There is no third prong coming up here for this. And of course, equipment like this vintage of equipment comes with, this kind of plug. Just a two-pronger, not polarized. And you can go in this way and you can go in that way. Usually in these devices, this leads just to the primary of a transformer and nowhere else. I wonder if we should just take another look at that. Why don't we just take a quick peek at that, since I plan to use that piece of equipment. Let me grab back the booklet here. Just take a quick peek, just to remind myself how it's done in here. So this is not your average device, of course. So this guy, he has a fairly extensive circuit up here that's coming right off the power. But none of this is connected over in here. Let's look very closely down here. So here you see in this case, they have capacitors and they have an inductor. They have actual filters built into the power line. Wow, that's pretty extensive. You don't usually see that kind of thing. So in this case, the case of this guy is hooked up here at these ground points through these capacitors. Now I looked at these look fine, they're very small capacitors. What happens if? So I'm liable to plug this into a regular outlet. That will present a hydro neutral, not a ground wire, but a neutral wire, almost the same thing, to one of these two prongs. That's going to have a bearing on this circuit, which is all contained inside the machine. Well, before we make a connection, any kind of connection between this and this, we'll get out a voltmeter and just look for dangerous voltages. That's got to be, always in the end, that's the best way of doing things. Okay, so we're ready to turn this guy on. You remember everything. Power switch here. Selector for radio over here. Speaker selector here. As long as it's out, it's on. Sticking out. I think we're good. And the volume control down. Okay, so we're going to start on AM. AM comes with its own AM antenna. Okay, there's no power supplied yet. So let's do that. We're going to come through the dim bulbs. This guy's not connected, or nothing else is connected to it. Here we go. You see the signal meter come up? Ah, thumbs up. Whoops. We got one speaker going. Probably the wires came out. Oh, we're right out. Okay. Just turn the volume down. Pretty good hum coming out of this machine. Let me set this here. Yeah, I just poorly connected the other speaker. We have to do something better here. But for now, we're going to do this. Oh, did you hear that pop? Some DC sitting there. Now, that may have just been an unimportant discharge. But it might also indicate with a receiver like this that there's DC going into these speakers. It's possible. 117 volts. And a total of like 3-4 watts, mostly this light bulb here. Okay, both speakers going. Tune around a bit for fun. Yeah, radio's working. I may not pick up anything in here, but this meter's operating properly. Although it seems way high. It always seems way high. Okay, now we're going to flip to FM and see what we can get. We need an FM antenna though before we do that, or signal generator. We're going to use an antenna and see what we can get first. Let's see how this works out. Hang on to this wire. So. I slapped this together a little bit just now because the only purpose is to see if I can get there. Okay, make sure I connect to the FM. A little bit of static. I'm going to fix the speaker and the antenna wires here so they don't come apart. Okay, FM antenna hooked up, speakers hooked up. Let's flip the FM and see what we can get. Okay. Volume. That's really bad. I would expect to hear a hiss, right? Okay. So I do have a piece of test equipment connected, which maybe is interfering here, or did I do something wrong? Did I do something wrong? First of all, is it really on FM? FM. Is there anything else here that needs to be flipped? No. It says 0 reception. So the stronger FM stations are up in this area. There's just nothing coming from this radio. But as I said, I do have a little circuit hooked up which maybe is affecting this. Okay, so much for trying to receive from an antenna. I am now going to proceed. This piece of equipment, first thing we got to do is a little safety check about voltages between the chassis and other stuff like that. And if the equipment were working perfectly, maybe there's no concern, but this is old stuff. There's no reason to think it's all working perfectly, that's for sure. So I really think for my own sake I should do this kind of stuff here. Okay. So he is not plugged in, so I'm going to plug it into a regular outlet. Just double checking it's not connected to anything. Okay, non-polarized plug going in random. Okay, thing to keep in mind is the pilot light is not in there yet. This unit is now on. Okay, so we're going to look for voltage between the chassis here and here. 23 volts AC. I'm going to reverse the plug and we should see like 100. Let's see what happens. Okay, reverse the plug. I'm still seeing 20 or so. So we're reading through a capacitor, I'm pretty sure. And this suggests to me it's probably no dangers at all with connecting these pieces of equipment together. If this said 120, full line voltage, it still might not be dangerous, but you'd want to be awfully cautious before making the connection because you don't know what's behind the voltage. If it's coming through a resistor and still showing up as 120, or is it straight through and you're going to blow something up. Okay, so I think this guy's going. So he puts out a signal and this other radio has an antenna. Let's see where the signal comes out into here. And without making a direct connection, I'm going to lay this just kind of near the antenna. There's two possible signals coming out of this connector now. There can be one from the marker generator and one from the sweep generator. So the marker generator is off. The only output signal from here can be from this oscillator. And we're tuned somewhere in the middle here. Say somewhere around 100, somewhere around here. This guy is cranked up for all it's worth. It still may not be enough signal though to just leak into the antenna here. We may have to make a more direct connection, but let's try this. Volume up. Volume is full tilt. Right around in here. Now I am working with a piece of equipment I'm not 100% familiar with. but I'm pretty sure this is putting out a 100 signal. How do we know absolutely for sure? Let me turn a radio on here. Another radio. Okay, so this other radio is tuned to 100. Okay, we need more positive proof here. I'm going to get the radios just a little farther away than I need it. I'm going to go get a little radio. Just hang on for a minute. Also tuned to 100 megahertz. Come on, man. Let's put the light back in. Okay, I'll switch it off. On? Yeah, it's definitely on. What's happened to it? Just give it a minute here. Bring the output very close to the antenna wires here. Well, this is an unfortunate situation here now. Okay, let's try the other oscillator here. This one just doesn't seem to want to work now. Come on. That's not this radio. That's this radio you're hearing. Okay, so at least we have one oscillator working. Son of a gun. Look at what I did. So, not a lot we can do with just this one oscillator. We really need the sweep oscillator going. But what this proves is the receiver is receiving if you can give it enough of a signal. And this signal is reaching the radio through the antenna here. Very strong hum coming out of this guy, I think. Ooh. So this guy could be putting out a signal at every 4 megahertz, or actually 3, just over 3 megahertz. So if we go here, 93 on the, hey, this is microphonic. That's coming out of the speakers. Huh. Well, that's interesting too. I mean, somehow these speakers are decoding this. I don't know what to make of it. Oh, it's probably, when I bang on this, there's probably an FM variation going on in it. That's why we're hearing it. Okay, so that's around 93. So what do we get at 99? Nothing. You have to fool around with this an awful lot more. I did mention this is two things at once, right? A receiver with question marks and an instrument with question marks. Why didn't the sweep show up? That's really a sad situation. Let's just try it one more time. The sweep signal may be very low, so I don't know how to get it. Let's put one wire on. So that's one output lead of this guy. Marker amp off. Attenuator full. Sweep width minimal. Band D 100. A seems to be gone. Okay. So the next step here, which is a little hard to do without a sweep operating, is to connect the scope to this test circuit that I had built and installed here. It's nothing more than a demodulator circuit, but designed to not disturb the radio, I guess. Regardless of the fact that this isn't sweeping, I'm going to go ahead. I'm going to hook the scope up there. Then at that point I'm going to have to stop because I have to get this sweep. I have to get a sweep involved in this at some point. Why didn't my sweeper go? Okay, scope signal should be showing up. Now, the scope needs, to get something useful out of here. It's kind of interesting in itself. Well, you can't see it. So you see a bar, I see two lines going across, nothing in between. Or at least when I look at my TV screen, there you are. Now you can see there's just two bars there. What's going on with that? It's kind of a weird thing. So what's going on here is we have the channel 1 and channel 2 traces both on there. Let's get rid of one of them. Yeah. There we go. So that's now looking at that test point. Put this on ×1 here. There's just nothing there. Okay, that's it for now. That's it for now. I'm gonna rest and relax for a little bit. Okay, we're back in business here. You're hearing this radio. That's the sweep. That's the sweep width. All seems to be working again. So you can see I've added a clip lead here. I boobed up a bit and did not ground something properly when I put that back together. That's okay. We'll sort that out on a more permanent basis later. Now we're going to try to feed the sweep into the radio here. Now I've still only maintained one connection here. This one is disconnected. Okay, radio volume is up. Tuning is around 100. I'm going to set up the sweep width. We'll see if we can find it here. Nothing. Okay, so there's a fairly low signal coming out of here. I'm going to put it straight onto the antenna terminals. Okay, now we'll try it again. Really? There's something about this cable. Seems a little bit of a long shot, but it's a nice cool cable with a nice coil cord. coiled cord. I never liked these kinds of connectors very much. Amphenol, is that what they're called? Okay, I think that's connected now. The output should be here. We'll start with one of them again. I'm going to take off the antenna. Okay, just one lead connected. Come on, radio. What is going on here? What is going on? Just goes to show you how weak this other radio is. Okay, I'm going to hook up the other side of the signal. Okay, so we're going to be given a pretty good pumping action at this radio here. Everything on full. We're on FM. Volume up. Let me turn the volume down. Flip it on AM. Zero volume. What has happened? I can't hear a thing. Oh, I know what's happened. This isn't even switched on. Okay. Yeah, that's right. I cut the power to it. Power up. And volume down AM first. Okay, now we're cooking. FM. Oh, jeez. I gotta laugh at myself sometimes. Thank God, too. Okay, silly problems aside, we have a nice sweep now. Okay, so the next stage of this setup hookup is to get the scope going properly. There's a horizontal signal that comes out of here to drive the horizontal. There's a blanking thing that's happening. It should give us an interesting display, especially if I connect the scope up where it's connected here. We should get exactly what we're after. Oh my gosh, I've got 7 fingers crossed now. 7. Okay, so I've got the horizontal output from the signal generator going up here to channel 1. So we're going to flip this to XY. And look at that. We got something interesting there. This is a little too sensitive. Oh my gosh, look at that. Things have worked. I'm stunned. Really, really stunned here. So I believe what we're looking at is the wave shape response curve. That's what I want to say. Response curve of the FM radio in front of us. Now, I don't know much about it there. Now, what can be done next? Next, I can bring in the marker amp and see what that does on there. So, I'm just going to leave you looking at the scope for now. Flipping on the marker amp. Okay, we don't see anything. And then I'm going to change the frequency of the marker amp. Hopefully a pip will show up on there somewhere. Look at that really freaky image of me on the front of the scope there. Oh, there's something. Right there. Let me turn it up. Okay, so there's no real turning it up. There is a output amp level control is not doing anything. Okay, a few things. Let's turn up the attenuator. Oh yeah, it's not making any difference here. As I say, I'm not only trying to fix this receiver, but I'm also experimenting with this sweep. Here's the attenuator. Oh, that did something. Sweep width. Very interesting indeed. That's a faster and faster sweep. Is that the right way to put it? No, that's not the right way to put it. It's not faster and faster. It's wider and wider. Okay, so the little thing on the left there, I think that's the marker pit. Let's move the marker frequency around. Yeah, but there it goes, up the side and out the other side. But it can't stand out, I guess, where the actual signal is, which is a little bit of a problem. So I've got two little bumps there. Which one is the frequency? One bump there. I cannot get it to show up in the curve at all. It is kind of weird looking at my face on the screen there at the same time. I can tell you. Okay, well that's interesting. That is pretty interesting. Now what else can we do here? We have something called horizontal phase control, which I think will just... Oh! I noticed this before. I think it's supposed to move things slowly a bit, but for some reason it does that. It just flips them with a point of instability. I'm just turning this knob ever so slightly, just a few degrees back and forth to make that happen. So I'm not quite sure. I don't think that's working quite the way it's supposed to. So that's all pretty interesting stuff. What could we do now with this? I need to set up some more equipment in my shop here. Hey, this is going pretty well. Okay, here's an eyeful. So the first thing I'm going to do is I'm going to try to settle down my SDR a little bit by turning off some of the AGC functions. We'll see if we can get rid of it. So AGC not on here. Now there's another AGC or ALC located over here. Turn that off. And my experience with doing this is I can't make any difference. What I'm trying to do is stop the bopping. You see how that wave shape is bopping around on the SDR? I think that's the SDR response to this kind of signal. It's not intended to show this kind of signal at all. So it's doing its best, and that's what it comes out. So we just ignore the jumping and the bopping on it, and just look at the start and the stop. That's the important part. And generally the height of it, the average height of it. That gives you some idea of what's going on. If you look at the waterfall display below, you get an even better idea. So right now we can look at that and we can see the sweep is going from 103 to 104. It's 1 megahertz wide sweep. And I can shrink it down and down. Okay. Now the thing on the scope and the thing on the scope is coming out of this receiver. The thing on the SDR is being picked up right out of the signal generator, which you can't see is hidden back here. Okay, so that's what's going on. Now, I've probably changed the tuning relationship between these two guys. This guy's probably broadcasting at the wrong frequency for the receiver, so I'm going to change the center sweep frequency, that's what I should say, and see what kind of display we get on the oscilloscope. Interesting. So just kind of fill in the whole scope there. So I think as I increase the size of the sweep on the screen, you know, it's like the speed of light, it's always the same. It's the space that's changing. It's, you know, it's kind of like that in this. As I increase the sweep rate, sweep rate, is that the right word? Sweep width, the picture will shrink on the screen. Did you follow that explanation at all? There it is. So I just increased the sweep. You can see on the SDR I've increased it out, back out close to 1,000,000. Why do you need so much? So as I'm reducing the sweep now, sweep width, you can see that the picture is getting wider and wider, but at some point it's too wide. That's too wide. So we'll come back a little bit. Say, okay, I like that. Now let's make it a little bit taller if we can. Okay. The sweep is off right now. Well, look at that weird looking thing. What to make of that? So we don't know yet. We're nowhere near that point. Now it could be the center frequency of the sweep is still way off. Let me move it around here a little more. I think it's just going to go off the screen left or right. A little hard to move it precisely. Look at these weird shapes. So which one of those are really the shape of this radio? That's a good question. We're not close to figuring that out yet. So we'll bring in the marker and see if we can mark either side of the of that. Okay, marker on. I'm gonna change the marker frequency here. It's actually better that you watch this. If I swing this way, kind of see what I'm up to with the machine. Whoop, camera, come on, stand up. Okay, marker frequency here. It's showing up there just to the left, but when it starts climbing, what's happening? Everything's jumping around down the right. It doesn't look much different than when I just take two signal generators and beat them into the radio together. I get to get the same sort of display. So not much of a pip, is it? It's a big wide spot. That's the horizontal adjustment, which just doesn't seem to do much. And sweep width. So too big, and we come down, down, down. No, actually I'm increasing the sweep width. Now maybe I had it out too wide here. Maybe we do it like this. There's a funny little shape on the left side of it here. I'll move this around. So in order to do an alignment, you need absolute stability with everything you're doing, or other factors will cause you to do stupid things. Now how am I going to... So the challenge here is to slip the pip down the side of that response curve a certain distance, and then that's telling you the upper limit or the lower limit of the bandwidth is really what I want to say, the bandwidth of the response curve. And the whole idea is to try to detect it and measure it with this guy. But that's a pretty wide thing. Now there's no hope I can read the value off of this scale, but I do have another signal, another counter, another frequency counter I'm going to bring in here, and it goes up to 100 megahertz, so it should be able to count this. The challenge with that is this isn't the only frequency coming out of this beast. It's got the sweep, just going back and forth. It's got other stuff. It's got probably harmonics and other things that we can't even see right now. So let's pay attention again to the SDR. I'm going to just make this like this. In fact, maybe I'm going to full screen. No, I'll leave it the way it is because we can see what's going on the scope too. So now I'm going to fiddle around here a little bit I'm interested in what this crystal is doing, if anything. So this should be putting another mark around 3 megahertz away from where this is set. 3 megahertz away. So if we look on the SDR, let me vary the signal here and watch the SDR a little bit. So, you know, it's a real nice pip on the SDR. Look at that. It's really, really focused. But there's no... Of course, we're not looking at the wave shape now. What we're looking at is what's coming right out of the signal generator. And moving it to the left, and then right off. You can see it jumping around there. I was just holding on to the knob. Let me do it again. I'm holding on to the knob, and you can look at it jump around. This is the line on the left. You can really see it in the waterfall. And I let go of the knob. That's just from my hand influence. I put my hand on here. Whoops, I touched something. Oh, look at that. Now, is that from me shaking? It is. This is how sensitive this machine is. Oh my gosh. Wow. Okay, a little table wrap. Ooh. That's right, it's microphonic. We discovered it was microphonic. That's pretty interesting in itself. Well, yeah, crystal effect. So we see the this is set to something like 100 and almost 103. So we add 4 or take off 3 rather. Add 3 megahertz. Should be something at 106. Or take off 3. Should be something at 100. Let's go up to 106. Let's see what's there. It's 106. There's something pretty odd right in here. Okay, so I've pulled the crystal out, and that'll get rid of any crystal generated signals. Well, there they go. Look on the waterfall display, you can see what they were. 2 of them there. Shouldn't really be 2, shouldn't there? Put the crystal back in. It's pretty awkward. And there's the signal again at 106. What this is, sorry, I'm having some trouble pointing, but this thing right here, let's just see if we can identify what that is. It would look like the sweep of some sorts. I'm going to change the sweep width and see if that moves. Yeah. So exactly why that is there, I don't know. It looks like there's another sweep going from 106 to 107. You know, it's possible. Yeah, I don't know. The real sweep, though, is back here. Well, that could be an influence of this sweep happening here, and then getting duplicated, getting mixed with the other signals, and resulting in the sweep showing up in other places. Maybe. Oh, I really like the way the scope looks great now. Can you believe it? Can't believe any of this yet. That's the thing. I kind of need a radio that's working perfectly, and then I can use the test equipment against the radio, and then I can see, knowing the radio is perfect, that all the problems and weirdness must be coming from test setup or the equipment itself. But with a radio that's a little questionable, especially so weak in reception. So my question is, have I got myself to the point where I can start doing something useful to this radio? Bearing in mind I do have another FM signal generator, one that's got some excellent features. Far more appropriate for FM radios, that's this guy, than this one. But between the two of them, I think I got a fantastic setup here. All I got to do is just figure it all out. Figure it out, Jim. Okay, so thanks a lot for watching today. Tomorrow we'll pick up from here and try to work on the radio a little bit. Again, trying to exercise the new equipment I have, the new old equipment I have, and figure out the best way to approach this kind of stuff. Yeah. Okay, thanks a lot for watching.